Alrighty then, I guess we're ready to start on our test corrections for exam number 4. This is take 2. I did a first take, took me like 13 minutes to do this problem, and I just found out the volume wasn't turned on. So take 2 right now, here we go. So we're going to be graphing this rational expression here, 2 minus x over x squared minus 9. And the first thing that we want to do before we get to all this crunchiness over here is let's go ahead and factor this guy. So whatever is, that can be factored, then that would be really nice there. Okay, so let's just rewrite, let's see, the denominator as x plus 3 and x minus 3 there. Okay. Okay, so I just rewrote my function in terms of factored form now. And as we can see here, nothing crosses out, which is an indication that there are no holes in, right? We only have holes when a common factor is eliminated from the top and the bottom there. Okay, let's find the y-intercept. Well, the y-intercept is when you set x equals to 0. So when I replace x with 0, if this is 0, that means I have 2 on top. And if I replace 0 on the bottom, then I have negative 9 then on the bottom, which then means that that's our y-intercept, 0, 2 negative 9s. Okay? The x-intercept, that's when we set the numerator equal to 0. So if I set the numerator equal to 0, then that means if I move the 2 over, so that's negative 2, and then divide by negative 1, so it's going to be 2 then. Okay, so right now that just gave us 2 points. We have a y-intercept and we have an x-intercept. Vertical asymptote. The vertical asymptote only happens when we can figure out some value that makes the denominator 0. Okay, and so since it's already factored, x plus 3 and x minus 3, we just set each term equal to 0, and then we solve. So if I solve for here, if I want to solve for x, I would get negative 3. Then if I solve for right here, I would get x equals 3. So these are my 2 lines that are my vertical asymptotes. And as you saw on the exam, you would have missed out a half a point if you did not put the x. All right, so make sure that you're careful on that when you do the retake. Okay, come along here. What about the horizontal asymptote? Well, the horizontal asymptote only happens in 3 cases. All right, and so I'm just going to go ahead real quick and go over those right now. And so say if we have some type of polynomial, it's like we'll just say a to the power of x to the n over bx to the m, assuming that these are my leading coefficients and my leading terms. Then that means we have case 1. If n is less than m, then that implies that we have a horizontal asymptote at y equals 0. Okay? When the numerator is smaller, less than the denominator, then it will always happen that y is going to be equal to 0. Okay, that will be my line of my horizontal asymptote. Now, when the numerator and the denominator degree are the same, then that implies that we have a horizontal asymptote with the leading coefficients, a over b. Last but not least, when n is less than m, then that implies that we do not have a horizontal asymptote, but then that we have a slanted asymptote. Okay? So it is what it is. Go over here then. Horizontal asymptote. Well, if we go back and look at our problem here, and go to our original problem, as you can see here, the numerator is 1 and the denominator is 2, right? So our n is 1 and our m is 2, so n is less than m. N is less than m. So that means we have a horizontal asymptote at y equals 0. Okay? And obviously then we don't have a slanted asymptote. If you have a horizontal asymptote, then you don't have a slanted, or if you have a slanted, then you don't have a horizontal. So that means this answer would be none. And you got a point for just saying none. Okay. And you got a point here for saying no holes. And we talked about that in the very beginning because we could not eliminate a common factor from both top and bottom, which indicates that there are no holes. And lastly, additional points. Well, let's just go ahead and graph and plot what we have right now, and then we can see what additional points would be necessary for this guy here. Okay, so we have a y-intercept at 2 -9ths, which is a very, very, very small number, smaller than -1. So I'm going to just say it's going to be about right there. Maybe I'll do this in this color here. Again, this is, since we're dealing with fractions now, right? I'm just going to put it as close as you can approximately. You can't have anything precise when you're dealing like this on a coordinate plane, unless we stretched out like 1 to be like a factor of down here, and then we can cut these into fractions, but we're not doing all that kind of craziness. X equals 2 is the X-intercept. And what else? We have 2 vertical asymptotes. One at 3. One at -3. Oh, I went over one too many. Go over me. And we have, oh wait, one here. And we have another asymptote at y equals 0. Okay. So we still got a lot of work to do just to establish what this graph looks like. Unless you've seen these time and time out, then you would probably kind of know what the graph's going to look like. But if this is like your first time, probably don't have any idea what this graph looks like here. But let me just draw attention to this. Okay, we have these vertical asymptotes kind of break our coordinate plane into 3 separate parts. We have the left part, we have the middle section, and then we have the right section. So maybe let's pick a few points over here and see what happens, and then we'll pick some points in the middle, see what happens, and then over there on the right. So maybe like we'll pick -4 and -5. Okay, so let's just see what happens at those 2 parts. So we'll do f of -4 and f of -5. And this is just now mere computation work, but you just plugging it in into the numbers. And so I kind of did the work ahead of time here. So at f of -4, we get 6/7, and then at f of -5, we would get 7/16. Okay, so if we kind of look over here, well, 6/7 is almost 1, right? If this 6 was a 7, then that means it'd be 1. So it's going to be really close to 1. So I'm going to go to -4. It's about like right there. So it's super close to 1. And then look right here, -5, and then 7/16. Well, that's almost 8/16, which is going to be a half. So it's going to be about right there. And as you can see here, it's going to ride along this guy, and then it's going to have to come up and bloop. So just like that there. Okay. If you needed more points, you could apply -6, -7, -8, -9, just to make sure that it's going to just keep decreasing, which it will. Now, what about this madness? We have our y-intercept at that 2 -9ths. We have the x-intercept at 2, but what's happening maybe like at -1 and -2? And I don't know if you can kind of see this here, but let's just plug in -1. Let's plug in -2 and see what kind of stuff's going on there. And -1, we get -3/8. And at -2, we get -4/5. Once again, you know, -3/8. If this was a 4, then that would be -4/8, which is -1/2. So I'm going to pretty much just put it at -1/2. So I'm going to kind of go like right there. And if you go right here to -4/5, that's just about -1, right? Because if this is a 5, so I'm going to kind of go right there and make that like a -1 right there almost. So as you can see here, it's kind of looks like a straight line right here, right? I mean, that's pretty good there. And basically what's happening here is that if you try to do like -2, you're going to go down here, and the closer you get that you plug in -3, it's going to ride along this. So it's going to be an asteroid. It's going to cut across this whole thing here, and then it's going to go up. Now, it shouldn't be all crooked like that. Sorry, guys. This is just when I'm writing on my pad. But this should be a nice, smooth curve, goes all the way across, and then it comes up. And probably now that you have the exam, you probably put this in your calculator already and to see what it looked like. But you didn't have that kind of coolness on the test. So that's kind of like what happened there, is that this is going to ride along. And then going over here, if you know what the pattern is, these guys will never be on the same side. This is going to have to come over here. But you can plug in 4 and then plug in 5 right there. Okay, and that's going to conclude our first guide.